Hello everyone, welcome back to Maths by Harshit. So today I am coming with the two questions of NCERT of exercise 1.1, question number 2 and question number 3. So let's start the questions. Show that the relation, what the question said, show that the relation R, this is the relation on this in the set of R of real number defined as R equals to ordered pair A comma B such that A is less than equal to B square, and we need to prove that we need to show that this relation R on this set of real number is neither reflexive nor symmetric nor transitive. Okay, so what is the relation? Relation is ordered pair A comma B has to be here if they satisfy this property. Okay, now, and where A comma B both are real number. Here the set A is real number. So obviously this is a subset of A cross A. That is subset of R cross R. Okay. Now for reflexive. For reflexive. What we need to prove for reflexive? For reflexive we need to check is every element of set of real number is related to itself. We observe here that if we choose 0 belongs to R, 0 as a real number, 0 comma 0 belongs to relation R. Why so? Because 0 satisfy this property. Also, if 1 belongs to R, then we observe that 1 comma 1 also belongs to R. 1 less than 1 square. But as they both satisfy the reflexive property, okay, we can't say that satisfy by all the elements. Here we observe that 2 is also belongs to real number, but 2 is not less than equal to 2 cube. What is 2 cube? 2 cube is 8. So it implies that 2 is not related to 2. It implies that 2 comma 2 does not belongs to relation R. Okay, here you can take any number you can take which is positive, which is not equal to 1. Okay, and this property is not held. Okay, now, so it implies that as here exist there exists a 2 which is a real number which does not satisfy, which is not related to itself, hence it implies R is not reflexive on set of real number. Okay, next is for symmetric we need to check. For symmetric, okay, for symmetric means we observe that 1 belongs to real number, 2 belongs to real number. For symmetric what we need to check? If A comma B belongs to relation R where A and B both are real number, then is B comma A belongs to R or not. Okay, we need to check, and if this is true for each ordered pair then we can say it is symmetric. But here you observe that 1 comma 2 belongs to relation R. Why? Because we need to give reason. Because 1 is less than equal to 2 cube, that is 1 is less than 8. Property satisfy. Okay, but observe 2 is not less than 1 cube. 2 is not less than 1. Okay, so it implies that 2 comma 1 does not belongs to R. 1 comma 2 is there but 2 comma 1 is not there, so it implies that R is not symmetric. If this properties fail for a ordered pair, then we can say it is fail. R is not symmetric on R. Okay. Now, for transitivity, we need to check for transitive. For transitive, as they said, show. So we can, we need to take account. We need to bring a counter example. We need to write a counter example which counter this relation. Okay. So here I will choose. Suppose A is 10, B is 4, and C is 3. Okay. So we observe that 10 comma 4 belongs to relation R, and 4 and 4 comma 3 is also belongs to R. Why so? Because 10 is less than 4 square, and here 4 is less than 3 square. Okay. We need to check, but what happened here actually, 10 is not less than equal to 3 square. And if it is happening, then what we can say, 10 comma 3 does not belongs to R. 10 comma 4 belongs to R, 4 comma 3 belongs to R. So we need to check 10 comma 3 is not there, but 10 comma 3 does not satisfy the property, hence 10 comma 3 does not belongs to R. It implies that R is not transitive on set R. Okay. So here we proved from the equation number, I'll mention the equations. This is our equation first, this is our equation second. Okay. And this is our equation third. From equation first and second and third, we proved that relation R is not reflexive, neither reflexive nor symmetric nor transitive on R. Okay. I hope you understand this question. So let's come to the third question. Third question, what it says, check whether the relation R defined in the set 1 2 3 4 5 6 as this one is reflexive, symmetric or transitive. We need to check. Okay. So first of all, as set A is set A is here finite. What is set A? Set A is 1 2 3 4 5 6. This is a 6 element in a set A. Okay. And relation R is, relation R contain all those ordered pair for which B equals to A plus 1. B equals to A plus 1 we have here. Okay. And it is subset of A cross A. So if it is subset, this A and B belongs to A, obviously. Now, so let us find how many ordered pair come in R. If A equal to 1, B value 2. If A equal to 2, B value 3. If A equal to 3, B value 4. If A equal to 4, B value 5. If A equal to 5, B value 6. And if A equal to 6, if I put here, because A value of A may be 6 is possible. Okay. Value of A is 6 is possible. But problem is that here 7 come and 7 does not belongs to A. So this case we need to discard. Only these case we need to take. So the relation R will be 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6 is there. Okay. So how many elements are there? 5 elements are there. Okay. Clearly we observe that it is not reflexive. Why it is not reflexive? We can give reason that as none of the, here I am using none of the element of set A is not related to itself, not related to itself. Okay, so this implies R is not reflexive on A. Okay, similarly you can observe that 1 comma 2 is there but 2 comma 1 is not there, 2 comma 3 is there but 3 comma 2 is not there. For symmetric, what we need to check, as 1 comma 2 belongs to R but 2 comma 1 does not belongs to R, this implies R is not symmetric. R is not symmetric on A. Okay, now for transitive, observe 1 comma 2 is there, 2 comma 3 is there, but 1 comma 3 is not there. So as 1 comma 2 belongs to R and 2 comma 3 belongs to R, but 1 comma 3 does not belongs to R, implies R is not transitive on A. So here we can say again, what we can say, R is neither reflexive nor symmetric and nor transitive on A. Okay, I hope you understand this both the questions. So thank you for watching.